Welcome to our course today, and today we are going to tackle network topologies, and we start by defining the term network topologies. A network topology refers to a way in which computers, cables, and other devices have been arranged in a network. It can also refer to how data is passed from one computer to another in a network. We have two types of network topologies, and we have the logical and physical topologies. In the logical topology, we have the Ethernet and the token ring. The Ethernet topology is whereby all computers listen to the network, and a particular computer can only send data when none of the other computers is sending. And in token ring topology, a specific package of data called a token goes around the network, and then the computer whose address is on the data held in the token picks it up, reads the data, and then releases the token so that other computers can also transmit the data. Physical topologies, this refers to the physical arrangements of computer networks, and examples of physical topologies is the star topology, bus topology, ring topology, mesh topology, and we also have the tree or hierarchical topology. The choice of topology to adopt depends on the factors such as reliability, expandability, and performance. Star topology, as the first of physical topology we are going to handle today. So star topology consists of computers and other devices, each connected to a common central device called the hub. However, the connection to a central machine However, to connect to a central machine, each computer uses a separate cable. Nodes communicate across the network by passing data signals through the hub, i.e. N2, that is N2 computers, the workstations, that is in a network communicates through the central machine. The hub receives data from a transmitting computer. It broadcasts the message to all other nodes on the network. And and here we have a diagram to show how the layout of star topology. So these are the workstations. The workstations, we can have computers, we can have servers, printers, and other devices in a network. And this is the hub or the switch in which all computers are connected to. So we have the advantages of star topology. It allows key network resources such as connectors and servers to be centralized, easy to configure. It enhances operation safety. The hub isolates the network cables from each other. Even if the wire between a workstation and the hub breaks or develops a bad connection, the rest of the network remains operational. It's simple to control. It can be extended easily since each workstation is simply connected to the hub. Provides flexibility in adding and deleting devices. The wiring hub increases the flexibility for growth. Addition and remove of the nodes does not involve cutting or joining cables. It's easier to troubleshoot, that one we said. And then the last one is, in case something goes wrong in the network, the administrator can troubleshoot in it from the wiring hub. The hub can support multiple types of cables. Yeah. So we have the disadvantages of this topology, the star topology. So one of it, if the central hub or switch fails, that will mean that the entire network is down. And the second one, it's costly because each workstation is connected to the central connector by its own dedicated cable. Installing it takes a lot of time to install this kind of a network. That's the next disadvantages. And the fourth one, it may require special devices for signal generation across the network. So our next thing we are going to handle today is bus topology. It's also called a daisy chain topology. In bus topology, all devices in a network are connected directly through appropriate interfacing hardware to a single transmission cable called a bus or a backbone, on which information is broadcasted. So we have a central cable here. This where all the transmissions are broadcasted, and so we have the terminals, and each terminal is connected to the central cable here, the workstations. In this case, we have terminators at the end of each of the central cable, or what we call the backbone of the network. So we can go to what a terminator is. So a terminator is attached to the end of the cable to avoid the signals from bouncing back and forth on the cable, causing signal distortion. Signal distortion is the weakening of the strength of the signal, that is. So we use coaxial cables as transmission mediums. Bus topology does not require special equipment like the switch in case of the star topology that was just covered. So, and the last thing we're going to handle today, we handle the advantages and disadvantages of this topology. So the first advantages of this bus topology is that it's easy to install, it's less costly compared to star, of course, because it does not require a complete cable length per a computer. Can easily be extended. You just attach the nodes to the central cable. So it's easy to extend and expand. It allows the workstation to communicate independently and separately of each other. Failure of one workstation in the network does not necessarily affect the entire network. So the disadvantages is that if the main cable has an issue, it's not working, the entire network is down. The performance degrades since there is no signal integration. Troubleshooting of cable fault is quite difficult because the fault could be anywhere in the cable. It's only limited to a number of computers can be connected to the central cable or the backbone. And this means that if the number of computers increase, there will be more collision and hence slower transmission. That's all for today. The next lesson we're going to start from ring topology. Thank you very much for your time. Let's meet in the next lesson. Bye.